All right, so questions on 8.1 and 8.2a, we'll call it. That first page. Nothing? Why's your Chromebook open?
I don't know how to do like 22, like the first thing.
Okay, so look. So I've got 1, 2, 3, 4 things, right? I got to find where those 4 things go. Okay? So right here it says my given is M is parallel to N and L is transversal. So right here, this is going to go where?
In the given.
Yeah, it's going to go right there. That's going to be, we'll call it B because it's labeled B, right? Okay. Okay, then it says, okay, what angles are vertical? Well, the only option here are 7 and 5 vertical angles. They are? They're not, right? So the only other possible answer here is what? D, right? Okay. Then I've got 3 is congruent to 5. 3 is congruent to 5. Well, what is that? Corresponding angles, right? That's C. And then the transitive property. We talked about this the other day, didn't we?
Yeah.
Right? Well, that has got to be what makes 7 congruent to 5. That's got to be A, right? And that goes back to what we talked about. If I look at D right here, D would have said angle 7 is congruent to angle 5, right? And then that one, I probably would have actually needed to write that how. Anybody remember how this should probably be written? But no, shouldn't it have been angle 5 is congruent to angle 3? Because shouldn't these two be the ones that match up? And then there, what comes out as my answer? But that's what it wants. Does that make sense? Okay. 23 is just like it. Just pick out what goes there. Okay.
Except I feel like 23 is also confusing. So what?
Have you tried it yet?
Yes.
So where?
And I have no idea on like I'm confused on D.
So 1 is congruent to 4 and 2 is congruent to 3. 1 is congruent to 4 and 2 is congruent to 3. Well, what are they? Aren't they alternate interior angles?
Yes.
So shouldn't D be actually D? So isn't that what 1 and 4 and 2 and 3 are?
Yes. Wait, so then what's B?
So what's B?
Yeah.
Angle 1 and 3 form a linear pair, and angle 2 and 3 form a linear pair. Well, what does it mean to be a linear pair? I would probably say it's probably they're supplementary, right? And we're 1 and 3 and 2 and 4, that would have to be E, wouldn't it? Definition of supplementary, because linear pair and supplementary are almost the same thing, right?
Yeah.
Because by definition, linear pairs are supplementary because it means they add up to 180, right? So that would have been E.
Wouldn't E go with your F as the reason because that's what you're trying to prove?
Where at?
Wouldn't E go at the reason for F because that's what you're trying to prove? Or wouldn't it just go F and
So 1 and 2 are supplementary. And 3 and 4. So you're saying this would have been this, right?
Yeah, and then for
So
B,
angle
put the
1
3
and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. So now wouldn't that be C? Because it's 1 and 2 now.
Well,
Oh no, that would have been. That's actually this. This is my C, right? So then I think, yeah, I like your idea. Wouldn't that have been substitution? So aren't I just substituting 2 in for 4 here because of this? I think that would have been just substitution.
Wait, so C substitution?
Well, so C, F is C here. Because that's what it told me to prove, right?
Yeah.
Isn't that what it wants me to prove? That's my statement, my reason.
So what's A? Because I thought A was.
No, A's this. A's my given. A's my given. So A would have been F. Because that's what's given. M and N are transversal. That's what's given here. You see what I'm saying?
Do all of them before you.
So then C, if two angles form a linear pair, then they are supplementary. That is, yeah, I would say that's definition of linear pair, right? That could be A. Huh. Okay, we can't have that. Why can't you have that? Why can't I put that right there?
If two angles form a linear pair, then they're supplementary.
But that's not. Look at all the stuff over here, and look what A would do. A's got to be a reason, doesn't it? Because it's all. Notice everything over here is just what? Just words, right? Notice over here is not words. So I couldn't have A go right there. Couldn't do it. So that's got to be wrong. So let's look at that. So
C.
I would say probably 1 and 3 form a linear pair. 2 and 3 form a linear pair. I mean, you could go there. I mean, could I say definition of linear pair right there even? I could say probably put A right there. Because then that allows me to use my E right here, which then puts my angles back over here, right? Yeah, that would work.
Could you have put C at C?
Could I have put in C at C? No, because we've got to have, look at this. Look at what it wants me to prove. The bottom one is always what it wants me to prove. Notice it's 1 and 2, 1 and 2, 3 and 4, 3. That has to be down here. Has to be C, which is my only one left is E, right?
Wait,
Then D.
so the last F is.
Ooh,
substitution.
no, you're right. That can't be right. Because look. No, that is right. Because 1 and 4, alternate interior, that's right. So that has to be, that'd have to be E. Because that's the only thing left that would belong on this side, right? Is there anything left here that could go over here?
No.
There isn't, as far as angles, right? So then the only option would be these two, or D and B, right? So D is 1 and 4. No, that has to be right because that's alternate interior angle theorem, right? Yeah, it has to be right. So the blanks go FEC on the left, they go ADB on the right. Anybody have that way? I think that's right.
Wait, the last one's substitution?
Yeah.
How?
So when you take and so if you go back to right here, no, to right here. So this is E, right? 1 and 3 are supplementary, right? Okay, so if 1 and 3 are supplementary, that means they add up to 180, right? And now you tell me that 2 and 3 are the same angle, right? Well, that must mean that I can substitute 2 in wherever what was at? 3 was at. So I go down here and I say 1 and 2 are now also supplementary, and that's because I'm substituting 2 in place of 3. Yeah, that one took some thinking. That's what I would have done. How about 8-2, the first part of 8-2? That should have been easy. Yeah? Alrighty, so now what we're going to do is we're going to call it 8.2b and 8.3. Okay, so it is it 218 today? Today the 18th? 218, this is 5th period.
30 to 18.
And we need to get rolling. Yeah, it's moving right along, ain't it? So we're going to go 8.2b and 8.3. Our objective is going to be able to determine similarity and write similarity statements. Now, what you need to understand is that they're going to give you a couple of triangles.
I like triangles.
Okay, I like triangles too. Okay. Now, so if these are my two triangles, okay, and what you need to understand is there's a couple of things going on here. Okay, who knows what the term similar means? By definition.
Same, like the ratio.
Okay, so it's all about ratios. Similar is not equal. Do you understand what I'm saying? Okay, so what you need to understand is similar refers to triangles that have the same angles and proportional sides. Okay? Now, what you need to understand is this. If I tell you that this is 5 and I say that this is 10, okay? And I say that this is, I don't know, let's make this 15 and let's say that this is x plus 7. And I were to ask you to find x. Okay? Now, the first thing you have to assume, and I don't like how they covered this, is the first thing I have to do is in order to set up a proportion, I need to know whether or not these triangles are similar. Well, in order to be similar, the triangles must have the same angles, right? And they'll do that one of two ways. They'll either tell you by saying, you know, like, let's say I got A, B, C, and I got D, E, F, right? They will say that the measure of angle A is equal to the measure of angle D or something. No, that can't be it. A's got to be E, right? They'll say that, or they'll do like angle A is congruent to angle E, right? They could do it that way, or they could do what? What's another way they could do that? Anybody know of another way? Yeah, in this case, they would do like this, right? That's that, right? And then I would do maybe those two like that or something like that. And you really only need to know how many angles. Two. Why? Yeah, because if it's a right, well, if it's any triangle, they're going to add up to 180. Murray. Okay, so if I know two of them, I know the third one has to be the same, right? So what they're going to do is they're going to say, okay, here's a scenario. This triangle and this triangle are similar. Once you know that, I know that all the angles of this triangle are congruent to the angles of that triangle. Once you know that, then you can set up a proportion using the sides. Now, how do I know which side goes with which? Yo.
Well, you could put them on bottom or top, but the same sides are going to have to be at the same.
Okay, so I gotta make sure they're in the same place. So my proportion, remember, is going to look this equals that, right? So I've got to say, okay, here is my one angle to one I don't know anything about, right? This side is my one angle to the one I don't know anything about. So I know that 5 and 15 are in the same place. Does anybody know what the word for that is? To be in the same place in a triangle? We use the word earlier today? No, it's correspond. Correspond means to be in the same place, right? So these two sides are in basically the same place in those triangles, right? So I could say, well, that's 5 over 15. Well, how would I set up my other ratio to make that work?
10 over x.
Yeah, why's it got to be 10 over x plus 7? Exactly, right? So I got to say, well, I'm taking this right triangle over my left triangle there. I've got to do the same here. I would use my right triangle over my left triangle, right? Now, once I set this up, this should be what?
The same as
That should be easy because we literally just did like 12 or 15 of these, right?
Yeah.
So the difference between what we did the other day and what we're doing now is the other day they gave it to you and just had you solve it. Now they're going to force you to set it up and then solve it. They're just taking that one step further, right? So if I gave you this, let's say I gave you that, okay? But I didn't tell you anything else. Is there a way to know which side corresponds to which side in this drawing?
I guess you could just assume that they're facing the same way.
You could assume that, but there's actually a way to figure it out. You got an idea, Brindley?
Well, I know that the most common triangle is two sides, if it's 3, 4, and 5.
Okay, now we can't assume that, but you're right. But that is a good idea. Okay, but that's not what we're going after here. Well, look, both of these have an x in them, right? Okay, and that x would have to be the same number, correct?
Yeah.
Well, what do I know about this number compared to that number? I heard it. It's going to be bigger, right? Well, if this one's bigger than that one, doesn't it logically mean that it's got to correspond, that one being bigger than this one?
Yeah.
Right? Now, how are two different ways I could write this and have it still be the same problem? Anybody know? There's like 6 different ways we could do this problem. Would anybody come up with 2 of them?
You could do 3 times 4.
So you say an x over 3 is going to equal 2x plus 2 over 4. That would be one way, right? Left one over the right one, left one over the right one, they correspond. That would work. Anybody know another way I could write that and still have it mean the same thing, Natalie?
Would x over 2x plus 2 be equal to 3 over 4?
Could you do it that way as well?
Yeah.
Yeah. That's 2 of the 6 ways we could do that. Why is that possible? Yeah, because when I cross multiply, I'm going to actually end up with the what? Exact same thing.
Can you flip them?
Yeah, it doesn't matter. That's what I say. There's 6 different ways. I think there's 6 different ways. There might be 8 different ways you could write them, because it could be in the numerator or the denominator. But no matter what, you're going to end up with 4x equals 3 times 2x plus 2, right? Which is going to give you 4x equals 6x plus 6. Going to do what? Minus 6x, right? I'm going to get negative 2x equals 6. X equals negative 3. Anybody see a problem with that?
That couldn't work
Why couldn't that work?
because your sides can't be negative.
Yeah, can I have a negative length on the side of a triangle? So clearly I chose really bad numbers, right? I just pulled that out of my head. I'll have to make sure I fix that tomorrow. That's probably got to be more like, because if you look at the relationship, I'm going to take and times that by 2 and add 2. That needs to be further apart than 1. This should have been like an 8 or something. Then it probably would have worked. I'll fix that tomorrow. In fact, I'm going to make me a note of that. change that number. Oh, make it an 8. That should work. Alrighty, now, that is the 8.2b, because after that it's review. Now, here is, if you go to the objective, this is mainly what I'm talking about. Similarity statements. Now, what you're going to do is a similarity statement is going to be triangle something is similar to triangle something. Now notice, does anybody know what that is? It is the similar symbol, but does anybody really know what it is? It starts with a T. Yeah, nice. Good job, Natalie. It's a what? It's a tilde. Okay? I'm going to be honest, I don't even know where it came from. I know they use it in German, because I took German, but for what we do, that means similar. Okay? So what they're going to do is they're going to give you a couple of triangles. Sometimes they'll make them the same triangle, but what they'll do is this. Let's say I do something like this. And they'll do some of each. They'll give you the numbers. They'll do this. It's a little different animal. Okay. Now, a similarity statement says triangle this is similar to triangle this. But the most important thing is that the triangles must correspond. Meaning, wherever A is at in my triangle, what has to be in that same place? F. Why F? Because there the angles that correspond. So if I go A, B, C on the left, what do I have to do on the right? I have to go F, E, D. Because I went from 1 to none to 2. Well, from 1 to none to 2, I have to go from 1 to none to 2. They must correspond. Now, does that mean, though, that A, B, C, and F, E, D are the only way I could write that and get it right? No. Say what? C, B, A, and D, E, F. I could do that. How many different answers are possible here? Actually, 6. There's 6 different answers I could have here. 3 times 2 times 1. Combinations. You give me 2 months, I'll teach you all that. It's like my favorite thing's the Coke Freestyle machine. There's like 17,000 different drinks you can get at the movies.
And if you mix all of them together,
yeah, we're not counting
the
that.
mellow yellows?
But you think about it, yeah. Like there's like I've got mellow yellow, and then I can put like 7 different flavors in mellow yellow, right? So there's at least 8 different options.
Yeah.
Then you think about all my main drinks and then all my flavorings, and you times all them together, and it tells you how many options there are.
What is your total?
And in like 2 months, I'll teach you all that. Okay?
But what is your
Lime mellow yellow.
Okay.
Yeah, we're Junction fans because we have the mugs and the bucket, you know. And there's probably few things I enjoy more than dinner and a movie. You get my age, it's the little things in life, right?
What movie have you seen recently?
Pretty much all of them.
Did you see Tenet?
I did not. I'm not into
It's
that
pretty
kind
good.
of movie, but is it? What came out right before Tenet?
Wonder Woman.
Yeah, that was the last movie we saw.
For Top Gun.
I am actually, because I remember the original.
So good.
Yeah.
Dad, have you seen Tenet?
No,
So,
I'm not into that kind of.
so
You
like
can watch
scary
the movie
movies?
back.
Yeah, I don't do scary movies at all. No.
Have you seen the new one with Liam Neeson, called Sniper? Or the Texas Farm?
Yeah, it's not Sniper. It is. Actually, that was the last movie we saw a couple weeks ago.
The new Liam Neeson movie. The one where he's like the...
No, that's what he just said. Yeah, that was the last show we saw.
That was ours too.
Marksman. The Marksman. That's what it was called. It was good. Okay, now. So the other thing you're gonna have to do is they're going to get creative here, okay? And they're going to do things like this. So let's say I do this.
Scared.
Is it a trapezoid?
No.
They're crossing lines. Aha.
That's not a shape.
Okay.
Gang signs, right?
So they're going to do this, and they'll go like,
Oh.
you know, G, I, J, K, L. So they'll do something like this, right? And they'll say that, you know, this is x plus 2.
I don't like
This is x minus 5.
Oh, those are the angles
This
on top.
is, no, these are the sides. This is, you know, let's say that this is 12, and let's say that this is 10, right? And they'll say, okay, first off, I want a similarity statement. So I'm going to go triangle what is similar to triangle what. And then they'll say, in addition to that, they'll come down here and they'll say, well, I don't only want the similarity statement, I want you to find the measure of IJ. Okay? So, first thing I got to do is I got to figure out, okay, can I write a similar statement or a similarity statement? Well, in order to write a similarity statement, what has to happen? The triangles must be similar, right? But in order for those triangles to be similar, what has to happen?
And you have to know their angles.
The angles have to be congruent, right? Can I create a similarity statement?
No.
No?
Well, the sides. Wait.
In order to set up the sides, I first must know the angles, right? Can I generate a similarity statement here?
Yes.
Yeah?
No.
No?
Yeah, you can.
I'm trying to think
Yeah,
like
so
of
it's
because in the middle it's so they're parallel
Because the
lines.
sidelines are parallel, which would mean that the x intercepting has all the same angles. Right?
You're on the right track.
Oh, like the vertical.
Oh! So basically, don't I know that that angle and that angle are the same? So aren't they vertical angles? Right? And if these lines are parallel, doesn't that make GL a transversal?
Yeah.
Well, what does that make this angle and this angle?
Those are the same.
But it makes them, what would they be?
The interior.
Alternate interior angles. So when I have that and that like that, so now I've got my two angles, right? Well, by definition, then isn't I and K also the same? Yeah, so I could set up, somebody give me one of my potential similarity statements.
KLJ.
So you said what?
KL.
So I got KLJ. So if we go KLJ, what does my other one have to be? IGJ. Why does it have to go that way?
Because it's the transversal.
So I went
None to one.
none to 2 to 1. So I got to start with my none, go to my 2, and then go to my 1, right?
Oh, yeah.
Now I've got to set up my what?
Your thingies.
Yeah, my thingies. What's that called?
Same.
Starts with a P.
Proportion.
My proportion, right? So I'm going to go that equals that. Now I got to make sure I set them up right. And I already screwed this up. Damn.
What?
Did
What?
Yeah. I'll give somebody some Oreos
Oh,
if they can
okay.
tell me what's wrong with that picture I drew.
the thing in the denominator?
No.
Whatever.
No, I'm saying, like, what the Oreos.
Smedley.
I have no idea. That
No idea?
I want the Oreos.
Anybody?
Can I just have them?
J doesn't have anything. J doesn't have like.
No, it doesn't matter.
Quarter by Oreos.
Smedley.
You have an x squared.
No, that's an X plus 2.
Is it because you
Well,
have
what are you trying to
the?
access
Is
to
it because you have the x minus 5 and the 12 on the same line?
Okay, so look. So I'm looking at my X's, right?
Oh, wait.
So this is
Wait,
not too late.
wait, I'm ready.
But Freestone already got it.
Oh.
So I can't take X minus 5 and get a 12, an X plus 2 and get a 10, can I? Is that possible? Because the number X can't change, right? So we're going to get an ugly kind of answer there, right? So these should probably be what? Switch, shouldn't they? Does that make sense? Remind me to get them as soon as I'm done teaching. So let's switch them and see. And again, I made this up, so I'm hoping it works. Because when I do this, remember, notice the x minus 5 and the 10 are corresponding, right? Because that's between the 2 and the 1 and the 2 and the 1, right? So I could go x minus 5 over 10 is equal to what? X plus 2 over 12, and I'm going the left triangle over the right triangle, right? Then I'm going to do my whole vicity-do, right? I'm going to get 12 times x minus 5 is equal to 10 times x plus 2, correct? That's going to give me what? 12x minus 60 equals 10x plus 20, right? So I'm going to add my 60, minus my 10x, right? Minus my 10x, correct? Gone, 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 and I'm going to get 2x equals 80, x equals 40, right? Which now works out like we thought it would. Right now, am I done?
What is 40 minus 5?
Yeah, so the problem asked me to find I to j, right? I found x. Did I find I to j? No. So what's the answer here? The answer is actually going to be 42, isn't it? Because isn't I to j just x plus 2? Well, if x is 40, doesn't that make it 42? Now, understand how many steps we had to do to truly get the answer, right? You first have to generate a similarity statement. Okay? Your similarity statement is then going to allow you to set up your proportion, which then I can use to find my answer, my x, that then I can technically use to find my answer, which is what I asked you to find. So that's like a 3-step problem in reality. Okay?
Like story process where you have to draw a triangle.
Not right now, but eventually we will.
Ladder leans against
Yeah, technically they're today, but
The tree has
they're not bad. So look, let's look at one of those. So we'll do one right off the assignment. What are you whining about?
ninth grade.
Huh?
What are you whining about?
Oh, I'm just mocking last year's assignments because we do stuff like this where it's like you're standing at floor X and you see your shadow and you're trying to figure out this and then subtract the height you're at. And I just hate to do it.
Okay, well we're gonna do that. So let's say I did this. Let's say suppose
How tall are you and how long?
so suppose Brody sees his shadow
And winter will be 6 feet long.
that has a length of 6 foot 4 inches. Okay. At the same time, a flagpole that is
27 feet.
27 feet tall. Oh, hey. Glad to see you can join us today. Casts a shadow of
30 feet.
30 feet. How tall is Brody? Okay. This is exactly what it's the same thing. I would always do what? If I wanted to solve this problem, what would I do? I'd draw a picture.
But you first had to convert them all into inches.
You could do whatever you wanted. You could either put that as a decimal or put that in inches. I don't care. So this is what I would do. I would go, okay, here's my flagpole problem. This flagpole is 27 feet. This is 30 feet, right? Here's Brody. Oh, it's supposed to be in blue. Hard to be a lineman when you're that skinny. And this is 6 foot 4 inches, right? And this is basically where my X is at, correct?
Yeah.
Now we're going to assume they both stand up straight, so they both got right angles, right? And if I got the sun up here, right, I got the sun up here, they're going to have the same angles, right? Okay? So, based upon this, should I be able to set up a relationship?
Yes.
Yeah, so, what would I write? What's my proportion going to be?
37 and 27.
27 over X.
So you're going to go left over right. So if we went 27 over X is equal to 30 over 6.4.
Yeah.
No,
Well, it's
wouldn't
like
that be?
six and a third.
6.3.
It would be 6.33 repeating, right? Because 4 out of 12 is 1/3, which is that, right? Or I could have gone to inches. I don't care. Whatever you want to do. Right? I just times that by 12, times that by 12, times that by 12, and add 4 to it, right? We know how to get...
No.
Yes.
No?
Yes.
Ask your dad. He can probably tell you.
Only 5.
So, then this should be easy.
He's 5'8".
He's 5'8".
5 point.
Well,
5 what?
5.7.
5'7" is-
So 5.7.
it's 8 inches.
7 divided by, or 7.
I just turned it into a percentage and then did it into 12.
Oh, okay.
And then it got 8.
So you got 5'8".
Yeah.
You nailed it to the inch.
And you can.
See, it was funny because I was gonna make this 28 because I thought you were closer to 6 foot. You're taller than 5'8".
A little bit.
So,
Like 6.
5'6" 1.
but that's how we would do the problem. And this is probably, I would have went to inches because it's gonna give you a better answer. You know what I'm saying?
Why is it 6.33 repeating? Because you divide.
Because 6'4" is 6 4/12 feet.
Oh.
4/12 is 1/3. 1/3 is 0.33 repeating, right?
Okay. Yeah. Thank you.
But I probably would have went to inches if I was doing this because it would have given me a better answer. Yeah.
I'm confused though, because like when I put in 6 4/12 into an improper fraction, it says it's 19/3, but then when like
No. Watch. 6 4/12, right?
Yeah.
So watch. What they do is they just reduce this. They went 6 times 12 and got 72. Plus 4, they got 76 over 12, right? But watch. If I divide both of these by 4, I get 19 over 3.
But because it was reduced, then it wouldn't be right.
No, it'd be the same thing.
No, it wouldn't. Because 19/3 times 7 is like 100.
But it's 19/3 times 27, isn't it?
Well, what's 27?
Then divide 30.
Oh, yeah, okay.
Right?
Yeah, I see that. My bad.
Okay. So. That's it. That's the assignment. Okay. We got 5 minutes. Get your Chromebook out. Have you had your Chromebook out the whole time I was teaching?
No, I was like just opening it.
Okay. Okay, get busy.